right, some more algebra review as we get going into precalculus. Multiplying and factoring polynomials. So multiplying these two bubbles together, these binomials together, so this binomial times this binomial is going to require distributing this x through this other bubble, but also needing to distribute the positive 3 through the bubble. And this is very commonly called FOIL, to kind of summarize all of the multiplying that we do in a very cute acronym, you know. So F stands for the firsts, multiplying the firsts together, and then the O in FOIL, meaning multiplying the outer terms together, and then I for the what? The inners, and then L for multiplying the last terms in each bubble together. And so that's really, you know, so FOIL is just really summarizing all that, distributing. And so let's execute that now. X times x is x to the second. X times 5 is just plus 5x. 3 times x is really just 3x. And then positive 3 times positive 5 is positive 15. And then don't forget to combine any like terms that are combinable. Positive 5x and positive 3x make positive 8x. And so that would be the final answer there. Hey, nothing real different here. That's going to be x to the second. That's going to be when you multiply. Remember FOIL, and remember distributing is multiplying. We're multiplying these things together. So minus 2x, and then we have to do that multiplication, and then we have a positive 4 times a negative 2 to get negative 8. And then again, when we're combining like terms, this is a negative 2x, and this is a positive 4x. So a negative 2x plus 4x makes positive 2x. All right? Nothing different here. Just some repetition. Minus 1 is just minus x, and then a negative 1 times a negative 6 is positive 6. And then a negative 6x, remember technically this is a minus 1x. And so that's that problem. Okay, now changing gears, almost like going in reverse, okay? So now we're going to factor. Like now we're pretty much doing the opposite of multiplying. We're unmultiplying, you know, we're factoring. So hopefully I can make this a pretty thorough review of factoring, okay? So here we go. Point of emphasis number 1. There's many methods of factoring, you know, and the first method, though, that you should always try first. So the method you should always check for first is if you can factor out a GCF. You know, can you factor out a greatest common factor? In other words, can you divide the same thing from this term and this term and any other terms there might be? Is there a common term you can like divide out? And it turns out that you can divide a 3 and also an x. So, you know, you could divide 3x from both of those terms. And so you do that, okay? So dividing 3x, it's almost like you're undistributing, right? You're doing like the distributive property in reverse. So if you divide 3x away from 3x squared, there's an x left over. And if you divide that GCF from here, all you're left with is 4. And you can always check to see if you are right by, if you were to redistribute the 3x back in, would you end up with what you started with? And so if you do these multiplied together, you would get 3x squared. And if you multiplied the 3x back to here, that's right. Okay, so factoring by GCF is the first method you should always try. Now, if that doesn't work, the next method of factoring you should try is unfoil, which means, because x squared, 7x, and 10, those three terms do not have anything in common as far as factors go, so there is no GCF to divide out in front. So the next method is unfoil, which involves taking this trinomial and rewriting it as a binomial times a binomial, right? Basically doing FOIL in reverse. So remember, if the original problem up here just starts off with x squared, that means these two bubbles have to just start off with x and x. Okay? And if that is the case, if you're just unfoiling something that is just x squared out here, and your bubbles just start off with x and x and that's it, that way you can just finish off these bubbles by figuring out what two numbers multiply to get positive 10, but at the same time they also add up to positive 7. So this is something you may have to utilize here, is literally writing out all of the ways to multiply to get positive 10, which would be, really quickly, positive 1 and positive 10. But technically, people, negative 1 and negative 10. Also, you could have positive 2 and positive 5. And likewise, remember, technically, negative 2 times negative 5 gets me positive 10. But look, remember, whatever two numbers you're looking for also have to add up to positive 7. So here's all my four options. And since we're trying to add up to positive 7, I mean, this had no chance. This had no chance. I mean, very quickly you can see that it ends up being positive 2 and positive 5, which you could have put in the other order. Like you could have put the plus 5 here and the plus 2 here. Doesn't matter. And you could always double check. If you were to FOIL these back together, would you end up getting x squared plus 7x plus 10? And you would, and that's a way to double check. So number 6, is there a GCF? Nope. So let's try to unfoil. And it's going to be pretty quick and easy, because if it's just x squared, then we can start off our bubbles with x and just think about what two numbers like positive 1 and negative 12, but also negative 1 and positive 12, right? Moving on, plus 2 and negative 6, that's an option. But also that, switching up the signs. And don't forget about 3 and 4, where, again, if we're multiplying to get negative 12, then the signs on the two numbers have to be different. So positive 3, negative 4 is an option, but guess what? So is, oops, what am I doing? Negative 3, positive 4. And that's literally all the options I have that would get me that. But these two numbers also have to combine, add, to get negative 4. So which choice also works with the negative 4x in the middle? I'll tell you what. Positive 2 and negative 6, which you could have put in, you could have switched which bubble went with what one. But is there a GCF? Nope. So it looks like another possible easy unfoil, right? Where how do we get a positive 7 and a negative 8? Huh. Well, how do we get positive 7, positive 1 and positive 7, right? But that adds up to positive 8, which then you might think, oh yeah, negative 1 times negative 7 also gets me positive 7. And when you combine those, you get negative 8. So that's how you factor that one. Holy moly. Probably another one because there's no way there's a GCF. And so let's see if we can unfoil this. Remember, if it's just x squared, x and x, then you can think about all the ways to get negative 48. Again, you might not need to literally write all this out, but don't feel bad if you do. Sometimes I do. And then we got positive 2 and negative what? Don't be, if you need to use your calculator, you got to use your calculator. 3, I believe, would be, I think, so negative 16, but also negative 3 and positive 16. Because remember, it's a negative 48, so these pairs have to have different signs. How about 4? I feel like I'm going to run out of room here. Negative 12, right? Now, I mean, it's possible I already found the pair I'm looking for, but I don't think I did I? Because remember, I'm looking for also adding up to positive 2. So let's keep going. 5, does 5 work? Does 5, no. How about 6? Yes, sir. So positive 6 and negative 8. That makes negative 2, and it figures that the answer is actually the very last choice. So negative 6 and positive 8. It doesn't matter which one you put in which bubble. And we're good. Okay, number 9. Is there a greatest common factor? 2x squared, 6x, and negative 36. Turns out that there is a GCF, something that you could divide from all 3 terms being 2. So let's divide a 2 way out in front and divide it away from all 3 terms. Ooh, when we divide 2 from 36, we get, or negative 36 technically, we get negative 18. But guess what? You always need to check to see if it can keep factoring, So can this bubble be factored some more? And it would have to be by unfoil, wouldn't it? Like, there can't be another GCF. We already did that. So, I mean, we might as well try it. I guess, really, it depends on there being 2 numbers, because now it's just x squared, so x and x. It depends on whether or not there's 2 numbers that multiply to make negative 18, but they also add up to positive 3. So they got to have different signs because, it's negative 18. I got it. Positive 6 and negative 3. So, hey, there's an example of 2 doses of factoring. You factor out a GCF, but then, the 2 comes down, and this factor can be factored into 2 other smaller factors in a way. And here we go. Okay. Number 10. I think there's 3 more examples if my memory serves. So, is there a GCF? And you know what, by the way, well, I guess this won't end up being a very thorough, because I would also want to address factoring things like that by unfoil, but you know what, I'll probably get to that kind of factoring with the solving quadratic. So anyway, let's move on to this problem. Is there a greatest common factor? The answer is no. So now my thoughts turn to, would unfoil work? Maybe, but I definitely notice how the first term is not just x squared, it's 2x squared. And what that means is unfoiling is not then going to be so simple as, oh, both bubbles are going to just start off with x, and I can just think of the two numbers that multiply to get that. But when there's a 2 out in front, or a 3, or anything other than just 1, that complicates things. And there's many different ways to do this, but I'm going to show you something I call the Phoenix method. And what the heck, I'll also show you banana split method. Man, do you have your choices here. So here's the Phoenix method. Okay? What you do first is you multiply that 2, that's, you know, complicating matters, and you multiply the 2 to the last number over here. And in a way, you get rid of it temporarily. Okay? In fact, this is the Phoenix method. Basically, this 2 is the Phoenix. And we want the Phoenix to burn up, you know, for now, and go away. And so we take, again, we multiply that 2, that Phoenix of 2, by the 6. Now, doesn't this look like something we can do a whole lot easier by just making 2 bubbles that start off with x, and then thinking, okay, the numbers that do the job here for 12 and 7 are positive 3 and positive 4. But we're not done, okay? The Phoenix burned up into ashes. But now what do Phoenixes do? They rise again from the ashes. So remember, we sort of killed off the Phoenix by multiplication. What do you think we're going to do to bring the Phoenix back to life? The answer is by division. So now we're going to divide the Phoenix back in. We're going to divide it into those 2 numbers. And the final step or 2 is to take these fractions you just made, and if they can simplify, then you simplify. This fraction cannot be simplified. This fraction is just going to be like 2, or 2 over 1, right? And once you simplify, and I may as well do that, x plus, that's still really that fraction, but this is now just really a 2. If anything, you know, or 2 over 1, but 2. And if there's any denominators left over worth speaking of, they bump up in front there. You just kind of move it up in front of the x. And so your final answer, with that 2 bumping up in front, is going to be, this bubble is going to be 2x plus 3, and this bubble is going to be x plus 2. So that's the Phoenix method. The banana split method involves, you know, similar, I guess. And maybe I'll just clear, I'm going to clear this now to start anew. So here's the banana split method. Similar beginning, but different. When I multiply the 2 to the 6, you know, I get positive 12, okay? But that positive 12 is just going to be like in like a little thought bubble. It's going to be a number that I just kind of write down off to the side, because this first term is going to remain 2x, okay? And this final term is going to remain 6. So the first term doesn't change, the last term doesn't change, but the middle term is going to split, right? But the money question is, how am I going to split that middle term into two terms? Well, that comes into play now. Again, what two numbers multiply to get that positive 12, but they also add up to 7. And we already figured that out a second ago. Plus 3x and plus 4x. So at the end of the day, all we've really done is rewritten these 3 original terms as 4 terms. We now have 4 terms because we split the 7x into 3x and 4x, which is still 7x, just rewritten. And so here's the next step. Now what we do, since we have 4 terms, a very common method is called factoring by grouping. So I'm going to group these 2 terms together. I'm going to group these 2 terms together. And before I do the next step, this is why, someone named Caitlin O'Neill, I think, called this the banana split, because the parentheses look like bananas, and we definitely did a split here, right? So that's why it's called banana split. But once we bring the bananas in and we group these 2 terms together and these 2 terms, now what we're going to do is a double GCF. We're going to take a GCF out of this group, and we're going to look to take a GCF out of this group. Even if that GCF is just 1, we would still do it. But anyway, the GCF here is actually just x. Oops. Oh my goodness. Wow. I should have noticed that a long time ago. Anyway, still, the GCF is x. Sorry. Hopefully you noticed that like 3 minutes ago. Anyway, so that doesn't change. The GCF is just x. That leaves a 2x here and a 3. And then the GCF from this bubble is 2. Notice how I ended up with the same bubble left over both times, which that's a very, very, very good thing, because in our final answer, we're technically going to do another round of GCF, but you can just think of it as whatever bubble you got twice, that's going to be one of your final bubbles, and the other bubble is this x and this plus 2. And that's how the banana split method works. It just kind of involves eventually doing the factoring by grouping method. Okay, 2 more quicker examples now that I'm not going to re-explain everything. So these next 2 examples should go quicker. First, Phoenix, which involves doing that, and then, so what 2 numbers? I believe it would be -6 and +4. Now it's time to bring that 8 back to life by dividing, and it looks like both of these fractions will reduce. So it means I have this 2 to bump up, and I have this 4 to bump up, and so I think the final answer, or the final bubbles, should be like so. Okay? So unless I screwed something up in my rush, that is how you would do that with the Phoenix method. And as far as banana split goes, Let's see if there's something new I can point out, because there is something I haven't addressed yet with banana split. Let's see if that pops up here. So with banana split, I'm thinking I gotta have that negative 24 in the back of my mind. And so how do I split this up? Again, what two numbers, I just did this a minute ago. What two numbers multiply to make negative 24, but also add up to negative, so we got a plus 4x and a minus 6x. So that comes down, this comes down. All right, so let me address something. Like, this is a key detail that hopefully doesn't trip you up ever. When I go to group all these terms together, I want to group these two terms together and these two terms together. I want, like, I don't know, I want this to be like a clear, like what two terms are over here and what two terms are over here. So this is a pretty decent piece of advice. I don't normally do this, but maybe it's better to realize that this is like a plus negative 6x. And so when I group especially these two terms together, I know that it's a minus 6x and a minus 3. You know what I'm saying? So I like when you group these two terms together, just make sure you realize that it's a negative 6x and a minus 3, you know, that I want to be. It's not the only way to play it, but whatever. So GCF time, double dose of GCF. I could take a 4x as a GCF, which leaves 2x here plus 1. When I divide 4x away from 4x, got 1. All right, what's the GCF here? Okay. And if the first term is negative, you usually want to take out a negative as part of your GCF. So I'm going to take out a negative 3, which leaves 2x plus 1. Okay? And remember, if you're not getting the same bubble twice, then either like the method wasn't working out or you just made a mistake. You know, like if you don't get the same bubble both times left over, something's up, something's wrong. And so final answer would then be that bubble that you got twice, and then the 4x minus 3. Banana split. Okay, we just did that. So, okay, we're on the next one. Back to Phoenix. Final problem, right? So, I clicked on this color. So first we have to burn up the Phoenix, get rid of it for a little while. And that last term changes to 18. You know, hey, positive 18. This should be a minus 9 and a minus 2. That's what gets the job done. Time for the Phoenix to rise from the ashes back to life. So bring that 3 back in. And this is just going to be a 3. And this does not reduce, so the 3 bumps up. And so let's just jump to the final answer here. And that should be the final answer. So let's see if we get the same thing with banana split. So now this plus 18 is just off to the side, and so we got minus 9x and a minus 2x that middle term breaks up into. And again, like I want to clearly see what these two So it's a plus negative 2x, because I clearly want to know that it's these two terms in this grouping. And now we do what? We do a double GCF, which would be a 3x as a GCF, which leaves x minus 3 left over when you divide out the 3x. And again, if that leading term is negative, I want to bring out a negative GCF, which would be a negative 2. So dividing out a negative 2 leaves, all right, x minus 3, which means that one of my final bubbles is x minus 3, and the other final bubble is 3x minus 2. Oops. Okay. And that should be it, right? That is.